The Zoom session is being brought to you by the fractal on dyadic horizon, BL. All right. Another one of my favorite fractals. All right, for today, we will be going over the sum and difference trigonometric identities. We take a trig function of alpha plus or minus beta equals what in terms of trig functions of alpha and of beta. All right, we'll start with, well, the book has derives cosine of alpha minus beta, but I'm going to do alpha plus beta. We start with these two circles, unit circles, radius 1. Here we go counterclockwise an angle alpha. This point out here is cos alpha by sine alpha. Here we go that's a counterclockwise alpha. Here's clockwise beta, therefore an angle negative beta, to the point cosine negative beta by sine negative beta. Then we take this triangle, and we rotate it beta radians to get this triangle here with one point at 1 by 0, an angle alpha plus beta, and this point up here, cosine of alpha plus beta by sine of alpha plus beta. Now, since these are just rotated, all the lengths should be the same. In particular, this length here, between here and here, d, should be the same as this length d between here and here. So, same lengths, so their squares are the same. D squared equals d squared. Now, all right, the square of a distance equals the sum of the squares of the differences of coordinates. So this d square this d, it'll be this minus this, cos squared, plus this minus this squared. So that's cosine alpha minus cosine negative beta, all that squared, plus sine alpha minus sine of negative beta squared. That's d squared on this. Here, d squared here will be cosine of alpha plus beta minus 1 all squared here, plus sine alpha plus beta minus 0 all squared here. So we now have an equation. It's an identity, and we'll simplify it down to the cosine of a sum. So, all right, the left side, first cosine negative beta cancels out. It's just cos beta. Square of a difference is square minus twice product plus square. Cos squared alpha minus 2 cos alpha cos beta plus cos squared beta. Here the minus comes out of the sign, so it becomes a square of a sum, sine alpha plus sine beta. So therefore that'll be sine squared alpha plus 2 sine alpha sine beta plus sine squared beta. And here on the right side, we have a square of a difference. So we have cos squared of alpha plus beta minus twice cos alpha plus beta plus 1. And as before, we have a sine squared alpha plus beta. Now, let's rearrange things. Put the cos squared alpha next to the sine squared alpha here. Put this cos squared beta next to the sine squared beta here. Here we have a cos squared alpha plus beta and a sine squared alpha put next to each other here. And we have these other terms, minus 2 cos alpha cos beta plus 2 sine alpha sine beta. And on the right, minus 2 cosine alpha plus beta. Now, here's the thing. Cos squared plus sine squared is 1 here, and here, and here. So we get, after it simplifies drastically to 1 plus 1 minus 2 cosine cosine plus 2 sine sine. That equals 1 plus 1 minus 2 cosine of sum. All right, the 1's cancel. And we get minus 2 cos alpha, cos beta, plus 2 sine alpha sine beta equals minus twice sine of alpha plus beta. Now we simply divide throughout by negative 2. And we get cos alpha cos beta minus sine alpha sine beta equals cosine of alpha plus beta. And this is the cosine addition law. Cosine of a sum is cosine cosine minus sine sine. Now, let's change this beta to a minus beta here and here and here. So alpha plus beta becomes alpha minus beta. Cosine of minus beta equals cos beta. Sine of minus beta is minus sine of beta. And when you do that, the angle addition law turns into this angle subtraction law. Cosine of alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. Okay. Now, if in particular we substitute pi halves for alpha. The cosine of pi halves is 0, and sine of pi halves is 1. Then this will be cosine of pi halves minus beta. This term cancels out. This term just becomes cosine of beta. Well, what do you know? Cosine of a complement equals sine of the angle. You mentioned this before. And if we substitute pi halves minus beta here and here where beta is, and since pi halves minus beta is beta, then we'll get cosine of beta equals sine of pi halves minus beta. Okay, so this is the, we've seen this before, the complements law. Trig, cotrig of a function is trig of the complement of the function, here and here. All right, now we'll use this rule to find the sine of a sum, because the sine of something, you use cosine of pi halves minus that thing. So sine of alpha plus beta is cosine of pi halves minus of alpha plus beta. You can rewrite this as pi halves minus alpha, that minus beta. So now we have a cosine of a difference, but we already have a formula for that. Cosine of a difference is cos plus sine sine. So sine of alpha plus beta equals cosine of this difference. It'll be cos plus sine sine. Cosine of pi halves minus alpha, cos beta, plus sine of pi halves minus alpha, sine beta. But cos pi halves minus alpha is sine alpha. Sine of pi halves minus alpha is cos alpha. So sine of a sum, alpha plus beta, equals sine alpha cos beta plus cos alpha sine beta. Sine, cosine, cosine, sine. Now we can get a sine difference formula by substituting a negative beta in for beta here and here and here. And since cosine of negative beta is cos beta, and sine of negative beta is negative sine beta, therefore sine of alpha minus beta equals sine alpha cos beta minus cos alpha sine beta. So we now have several rules. Cosine of a sum is cosine minus sine sine. Cosine of a difference is cos plus sine sine. Sine of a sum is sine cosine plus cosine sine. Sine of a difference is sine cosine minus cosine sine. Go one more step. Let's find the tangent of a sum and of a difference. Well, tangent is sine divided by cosine. Therefore, tangent of a sum is sine of the sum over cosine of the sum. And here in the numerator, sine of alpha plus beta is sine cosine plus cosine sine. Cosine of a sum is cos alpha cos beta minus sine alpha sine beta. Now I'm going to do a little trick. We'll divide numerator and denominator by cos alpha cos beta. All these cosines here and here cancel out. We're left with sine over cosine alpha, plus sine beta over cosine beta. All that divided by 1 minus sine over cosine alpha times sine over cosine beta. But these are tangents. Tangent, 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 tangent. And so you get the tangent of a sum is tangent alpha plus tangent beta over 1 minus tan alpha times tan beta. This is the tangent summation formula. Now, as before, we'll substitute negative beta in for beta, so this becomes a tangent of alpha minus beta. Tan negative beta is negative tan beta. Tan negative beta comes outside, and then it turns into this into a plus. And therefore, tangent of a difference, tan alpha minus beta equals tan alpha minus tan beta over 1 plus tan alpha tan beta. So, in summary, here we go. Cos alpha on alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Cosine of alpha minus beta is cosine alpha cos beta plus sine alpha sine beta. Sine of a sum, alpha plus beta, is sine alpha cos beta plus cos alpha sine beta. Sine of a difference, alpha minus beta, is sine alpha cos beta minus cos alpha sine beta. Tangent of a sum is tangent plus tangent all over 1 minus tan times tan. Tangent of a difference is tangent minus tangent all over 1 plus tangent times tangent. Okay, and you'll find these rules listed in the book, but I'm putting them here for you to see where they are. Okay, for example, then, let's find cosine and sine of 75 degrees and of 15 degrees. Cos 75, it's cosine of The 75 is 45 plus 30. So you get cos 45, cos 30 minus sine 45, sine 30. Cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Sine of 45 degrees is root 2 over 2. Sine of 30 degrees is a half. And if you take this and simplify it, you get root 6 minus root 2, all that divided by 4. Sine of 75 degrees, well, 75 is 45 plus 30. So this will be sine of 45 plus 30. That's sine 45 cos 30 plus cos 45 sine 30. Sine of 45 is root 2 over 2. Cosine 30 is root 3 over 2. Cos 45 is root 2 over 2. And sine 30 is a half. And this, after you combine all these fractions, comes up to root 6 plus root 2 over 4. These are fairly obviously closely related. Now, for cosine and sine of 15 degrees, these, well, 15 is a complement of 75 degrees. Cosine of 90 degrees minus 75 degrees. And because of the complements law, this will be sine of 75 degrees, which we already figured here. That's root 6 plus root 2 all over 4. Likewise, sine of 15 degrees is a sine of the complement, 90 minus 75 degrees. And again, we get by the complements law, this will be, therefore, will be cosine of 75 degrees, which we figured out from here is root 6 minus root 2 all over 4. Now let's go on, tangent of 75 and 15. Well, okay. 75 is 45 plus 30. So that'll be tan plus tan over 1 minus tan. So tan 45 is 1. Tan 30 is 1 over root 3. 1 minus 1 times 1 over root 3. This compound fraction. We'll multiply numerator and denominator by root 3. And we'll get root 3 plus 1 over root 3 minus 1. Now, okay, this is one we can simplify by rationalizing the denominator. We'll do that by rescaling the fraction, multiply above and below, by the complement, or whatever, the conjugate of the denominator. So instead of root 3 minus 1, we'll multiply above and below by root 3 plus 1. Sum, difference times sum is a difference of squares, root 3 squared minus 1 squared. That's 3 minus 1 over 2. Here, root 3 plus 1 times root 3 plus 1, which a bit of multiplication later, 3 plus 2 root 3 plus 1, 4 plus 2 root 3. All that over 2, and some 2's cancel, and you're left with 2 plus root 3. It's a tangent of 45 degrees. Tangent of 15 degrees is the tangent of the complement of 75 degrees. And so that'll give you a cotangent of 75 degrees. And a cotangent is 1 over a tangent, so 1 over tan 75 degrees. So 1 over this, 1 over 2 plus root 3. We rationalize this denominator by multiplying above and below by the complement, conjugate, excuse me, of the denominator, which is 2 minus root 3. And the numerator, 1 times 2 minus root 3 is just 2 minus root 3. And the denominator, 2 plus root 3 times 2 minus root 3 is 2 squared minus 3 squared, root 3 squared. That's 4 minus 3, which is 1. And so in the upshot, you get 2 minus root 3. What do you know? We've just figured out cosine, sine, and tangent of 75 and 15 degrees. All right, so some examples from the book, but these numbers are probably no longer fit the present edition. All right, so here they have a proof question. Well, as I mentioned before, proof problems, it's not sufficient just to say the answer is true or false. You have to go show some of the steps to prove that it is an identity. So prove a sine of 3 pi over 2 plus theta equals minus cosine theta. All right, this is a matter for the angle addition rule. The left side is a sine of a sum, 3 pi over 2 plus pi. And a sine of a sum is sine cosine plus cosine sine. Sine 3 pi over 2 cos theta plus cos 3 pi over 2 sine theta. Now 3 pi over 2, that's 3 times 90 degrees. It lands you here at the point 0 by negative 1. So the cosine is 0. The sine is -1. And if you multiply this by -1 and this by 0, you get minus cos theta, and that's the right side, and it's proven. Here, let's try cosine of the arcsine of 5/13 minus the arctangent of 3/4. Okay. So this is a cosine of a difference. So it'll be cosine, cosine plus sine, sine. Cosine of arcsine 5/13, cosine of arctan 3/4, plus sine of arcsine 5/13, plus sine of arctan 3/4. So I draw some test triangles. Here's a triangle whose angle here is 5, arcsine of 5/13. So we put a 5 opposite and a 13 on the hypotenuse. And by a bit of Pythagoras, it follows that this side is 12. And so cosine of the arcsine 5/13 will be adjacent over hypotenuse, 12/13. Cosine of arctan 3/4. Here's a right triangle, and this angle is arctan 3/4. So opposite over adjacent is 3/4. So put a 3 here and a 4 here, and this side by Pythagoras will be 5. And cosine of this angle then is adjacent over hypotenuse, 4/3. So far, 12/13 times 4/5. Plus sine of arcsine 5/13, that cancels 5/13. Sine of arctangent 3/4, well, we see it here. Here's an arctan 3/4. Sine is opposite over adjacent, 3/5. So 12/13 times 4/5 plus 5/13 times 3/5 comes out to 48 over 65 plus 15 over 65, and therefore 63 over 65 is this cosine. All right then.